This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on transformations of functions. Let's look at the function f of x is x squared. 0 squared is 0, negative 1 times negative 1 is positive 1, 1 times 1 is positive 1. 2 times 2 is 4, negative 2 times negative 2 is also 4. So we have 5 points to help us define this graph. As we graph those 5 points, you'll see that we get this figure. And when we connect those together, we have that parabola. So that is our function f of x is x squared. But we want to do something with that. We're going to transform that function. How? Well, I'm interested in taking that function f of x and subtracting 2. The function f of x was x squared, so now we're going to graph x squared minus 2. So here's our table for x squared that we saw before. Now for f of x minus 2, f of x is 0. If I subtract 2, 0 minus 2 is negative 2. 1 minus 2 is negative 1. 1 minus 2 is negative 1. 4 minus 2 is 2, and 4 minus 2 is 2. So f of x minus 2, f of x column, all subtracted 2. And now we have those 5 points. Now what would that look like? So we had our original graph that was here, and you'll notice that all of those red dots were shifted down 2 places. This was at 4, shifted down 2. This was at 1, shifted down to negative 1. This was at 0, shifted down to negative 2. This was at 1, shifted down to negative 1. This was at 4, shifted down to 2. So we have this original blue parabola, which was f of x is x squared. Now f of x minus 2, you take that function and subtract 2 from everything. And what will that look like? Of course, we get this. So you see our original parabola, and then the entire parabola is shifted down 2 places. That's how we transform that graph, by starting with f of x and then going to f of x minus 2. A vertical shift down 2. Let's change the function. Let's look at g of x. G of x is the square root of x. So we want to choose values for x that are nice, that have nice square roots. Square root of 0 is 0. Square root of 1 is 1. Square root of 2 is not nice. It's got decimals. But square root of 4 is 2. And square root of 9 is 3. So I would argue that these are good points to start with as we are looking at this graph, which we have those points 0, 0, 1, 1, 4, 2, and 9, 3. So if we connect those, we get this graph. Now, what are we going to do with that? So our original function, g of x here, is the square root of x. That's the blue graph. What I want to do is I want to change that. So how will I change that? So here's our square root of x function. I want to graph g of x plus 3. G of x is the square root of x. Square root of x plus 3. So we take all of these numbers in the g of x column and we add 3. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. So now I have these 4 points. So we have our original graph here for square root of x. I'm going to go ahead and add those 4 points to see what's happened. So you'll notice everything's been shifted up. How many places? 0 to 3 shifted up 3 units. This point shifted up 3 units. This point shifted up 3 units. This point shifted up 3 units. So our blue graph here is g of x is the square root of x. And the green dots will give us g of x plus 3, or the square root of x plus 3. When we connect those together, that's the graph we get. So you can see how we can add a number to a function, whether if it's a positive number, that graph will be moved up. If it's a negative number, that graph will be moved down. A vertical shift comes when you add a number to a function. Well, our next example is a little bit trickier. We've got f of x is x squared here, that we looked at before. But now I'm interested in f of x minus 1, where we are moving that in the argument of the function. We're replacing x with x minus 1. Not the same as f of x quantity subtract 1. This is f of quantity x minus 1. So if I replace x with x minus 1, I get x minus 1 quantity squared. So I just chose some numbers here to get a feel for how this works. 0 minus 1 is negative 1, squared is positive 1. 1 minus 1 is 0, squared is 0. Negative 1 minus 1 is negative 2, squared is 4. 2 minus 1 is 1, squared is 1. Negative 2 minus 1 is negative 3, squared is positive 9. 3 minus 1 is 2, squared is 4. Negative 3 minus 1, negative 4 squared is positive 16. So I have a whole bunch of points here. I'm going to graph a few of those. And what will they look like on the graph? So we know what the graph of x squared looks like. We looked at that earlier, right? Here's our graph of x squared, 0, 0, negative 1, 1, 1, 1, negative 2, 4, 2, 4. But if I plug in those other points that I had, notice what happens. 1, 0 is here, 0, 1 is here, 2, 1 is here, negative 1, 4 is here, and 3, 4 is there. So I have all of those points there, but what's happened? How has the original graph changed? This, my starting point, moved 1 unit to the right. This point moved 1 unit to the right. This point moved 1 unit to the right. Moved 1 unit to the right. Moved 1 unit to the right. So when we replace f of x with f of quantity x minus 1, you can see that every point shifts in the right direction 1 unit for that. And you can see the entire graph, in essence, is picked up and moved 1 unit to the right. That is a horizontal translation. F of x minus 1 will correspond to doing what? Moving it 1 unit to the right. What about moving something to the left? If I have a function, what can I do to identify that process? Let's go back to our g of x is the square root of x. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. But I want g of x plus 2. G of x plus 2. Well, you'll notice I chose to keep these numbers on the right the same, 0, 1, 2, 3. So to get a 0 here, I need a 0 on the inside, so I needed a negative 2. Right? Negative 2 plus 2 is 0. Square root of 0 is 0. If I have a 1 here, I need to have square root of 1 is 1. I need a 1 on the inside. So negative 1 plus 2 is 1. Square root of 1 is 1. If I have a 2 over here, square root of what is 2? Square root of 4. So x plus 2 would have to be 4. So x is 2. If I have a 3 here, square root of what is 3? Square root of 9 is 3. So I need a 9 inside. 7 plus 2 is 9. Square root of 9 is 3. So I've taken my original function here, square root of x, and I have created a table for the square root of x plus 2. Obviously, you could just plug these numbers in. Negative 2 plus 2 is 0. Square root of 0 is 0. Negative 1 plus 2 is 1. Square root of 1 is 1. 2 plus 2 is 4. Square root of 4 is 2. 7 plus 2 is 9. Square root of 9 is 3. But the trick is determining where those numbers should be. Now, when we had f of x minus 1, that shifted it 1 unit to the right. How is the shift going to work here? Here's our original graph, square root of x, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And if I go back to this table, now I want to graph those points. What does that look like? Negative 2, 0 is here. Negative 1, 1 is here. 2, 2 is here. 7, 3 is here. So where's the shifting? You can see the original graph has been shifted which way? This point is now over here, has been shifted 2 units to the left. This point over here shifted 2 units to the left. This point over here, 2 units to the left. This point, 2 units to the left. So g of x plus 2 took our original blue graph and shifted everything 2 units to the left. So that's how that thing's going to work. If we would connect those points up, indeed we would have our graph showing us that that's been shifted 2 units to the left. So we should connect those up. So I will let you do that or think about it. My next example is going to be f of x is x squared. And here we go, our usual table for x squared. And here I want to graph the opposite of f of x. How is that going to change things? Or negative x squared if f of x is x squared. The opposite of f of x is negative x squared. And using the same values, all we do is change the signs of the f of x. Negative of f of x, 0. Negative 1, negative 1, negative 4, negative 4. So here's the graph of f of x together with those points. So if we connect those together, you can see all I've done is I've flipped this upside down. Taken the f of x values, multiplied them by negative 1, now we have an upside down parabola for us to work with. So multiplying a function by a number like negative 1 enables you to just multiply the original values of the function. That's all we did here. Here's f of x, multiply the values of the function. But in terms of a dynamic way of looking at this, multiplying by negative 1 flips the graph over the x-axis. A way for us to think about it. Okay, what about multiplying a function by something else? Let's say by 3. I have g of x is the square root of x. I'm interested in graphing 3 times g of x, which is 3 times the square root of x. Here's the numbers we used before for square root. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Why do I use these? Because they work out nicely. And now I want to graph 3 times g of x. 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. And if we look at that, what do we have? There's our original function for g of x. Root 0 is 0, root 1 is 1, root 4 is 2, root 9 is 3. But if I multiply everything by 3, what's going to happen? 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. So in a sense, we've stretched the graph. Multiplying by a scalar can be thought of a stretching or a compression of the graph. And putting all that together, you see our original graph here for the square root of x. And then you see what happens when we multiply that by 3. Just looking at the values in the table is a good way for you to see how that works. Well, the last thing I want to look at in this lesson is a complex sort of function for us to graph, polynomial function in this case. Y is 2 times x plus 1 squared minus 5. So we're going to start with x squared. So we know this is what we're looking for. I need x plus 1 squared times 2 minus 5. But our original shape is going to be x squared. That's our original function. So again, 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So there's our parabola. There is x squared. What I want to do next is I want to go to x plus 1 squared. So if I go to f of x plus 1, that's going to shift everything to the left. So x plus 1 squared, take all of your x values and subtract 1 to move them to the left. This red dot moves to the left, moves to the left, moves to the left, moves to the left, moves to the left. If you want to think of that in terms of the table, 0 minus 1 is negative 1, 1 minus 1 is 0, 0 minus 1 is negative 1, 1 minus 1 is 0. In essence, I took this x column and subtracted everything by 1 to get it to move to the left. So what we have here now with the blue dots are giving me x plus 1 squared. Now that's not what we want, but that's a pretty good start. What we want is we want 2 times x plus 1 squared. So again, here's our blue dots for x plus 1 squared, removing the original ones. If I want 2 times x plus 1 squared, we're going to double all these numbers. 2 times 0 is 0, 2 times 1 is 2, 2 times 1 is 2, 2 times 4 is 8, 2 times 4 is 8. You see those numbers? So there's the x values and there's the y values for 2 times x plus 1 squared. We'd like to graph those and see what that looks like. You'll notice it stretches. Multiplying by a constant is going to stretch. If it's a negative constant, we'll flip it over the x-axis. Positive constant, we're going to go ahead and stretch that. So the last thing we need to do is we need to take 2 times x plus 1 squared minus 5. So here's the x plus 1 squared column. Double all that. Now let's subtract 5 from this column. 0 minus 5 is negative 5. 2 minus 5 is negative 3. 2 minus 5 is negative 3. 8 minus 5 is 3. 8 minus 5 is 3. Here's the x column. Here's the y column. So I'm going to graph negative 1, negative 5. I'm going to graph 0, negative 3, negative 2, negative 3, 1, 3, and negative 3, 3. And what does that look like? So you can see what we've done. We've taken the blue dots and everything is shifted down 5 units. Down 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This was, again, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So the blue dots were 2 times x plus 1 squared. The green dots are 2 times x plus 1 squared minus 5. And if we connect those green dots, what does that look like? There it is. So we have 2 times x plus 1 squared minus 5. We started with a graph of y equals x squared. Then we constructed the graph of y equals x plus 1 squared, shifting everything to the left 1 unit. And we constructed the graph of 2 times x plus 1 squared, doubling all those y values. And then subtracting 5, shifting everything down 5 places. And that will complete this lesson.